right, we're going to be doing non-proportional linear relationships, and you're going to learn how to identify a non-proportional relationship versus a proportional relationship. Make sure you have the guided notes, and let's go. A relationship is non-proportional if the ratio between the two quantities is not constant. So that means if I have, like, let's say a table, and I do my y over x for each set of numbers on here, it would not be the same number every time. So that means it is not proportional. All right, real quick, little summary. So for tables, the ratio of y over x is not constant. It does not contain the point 0, 0. So whenever we look at a table, you look for your x is 0, your y is not going to be 0. Instead, when x is 0, y is a non-constant, non-zero constant, so it would be 0y, where y is just any number beside 0. On graphs, the line will not pass through the origin. So it will not pass through the point 0, 0 on the graph. Instead, the graph will cross the y-axis at a point known as the y-intercept. So for a proportional one, it would go right through that middle point on the graph, but if it's non-proportional, it's going to go through any other part except for that. All right, let's do a couple problems together. So at Pizza Palace, Rashid orders a pizza that costs $8 plus $2 per topping. Complete each representation to show the relationship between the number of toppings, x, and the total cost of the pizza, y. Then answer A through D on the following slides. All right, so if he has 0 toppings, so it's just a cheese pizza, he is still going to pay $8 because you pay the $8 initial fee, plus it's $2 per topping, and our toppings are x. But if he doesn't get any toppings, 2 times 0 is just 0. So now let's say he gets one. He gets a pepperoni pizza. He's going to pay the $8 for the pizza plus $2 per topping, and he got 1. So 2 times 1 is 2, plus 8 is 10. Let's say he gets pepperoni and mushrooms. That sounds good. He's going to pay the $8 for the pizza plus 2 times each topping. So he's going to have to do 2 times 2, which is 4, plus 8 is 12. So it'd be $12. Now he gets pepperonis, mushroom, and pineapple. So he's going to pay $8 for the original, plus 2 times however many toppings, and he got 3 this time. So 2 times 3 is 6, plus 8 is 14. And last one, let's say he gets pepperoni, mushroom, pineapple, and black olives. He's going to pay $8 for the original. And then he got 4 toppings this time, so he's going to do 2 times 4, which is 8, plus 8 is 16. So notice, this $8 right here is not changing because he has to pay $8 at least, regardless of how many toppings he gets. And notice the 2 does not change because he's going to pay $2 per topping that he gets. The only thing changing is this number right here, which is our x. So now let's graph these points. So for 0 toppings, he still had to pay $8. And notice, toppings are on our x, costs is our y. If he gets 1 topping, it's going to be $10. So I'm going to go over 1, up 10. 2 toppings would be 12. 3 would be 14. 4, 16, and so on. And we could use this to determine how much it's going to cost. So now we have to come up with the equation. So remember, it's going to be y equals mx plus b. So we can do this either by using the table, by looking at the graph, or by reading the problem. So let's use the table. So for each time the topping goes up 1, the cost goes up 2. So to find m, you do the change in your y. So our change in y over change in x. So that would be 2 over 1 or just 2. So our m is going to be 2. Our b, or our y-intercept, is where it crosses the y-axis or where x is 0. So when he pays $0, or when he gets 0 toppings, he pays $8. So that means our b is 8. And you can also do this by looking at the graph. So I'll find 2 points. We'll do this one, and we'll do this one. It goes up 1, but if you count on the side, that's actually going up by 2s, because 10 to 12 is 2. And then it goes over 1. So rise over run would be 2 over 1, or just 2. And then for B on the graph, you look where it crosses the y-axis. So that's at 8. So you can use either one. You could even use the word problem, and I'll do that real quick for y'all. So it says he orders a pizza that costs $8 plus. So, okay, we got to add. That's plus $2 per topping. When you see per topping, per cake, per game, whatever, that means you're going to multiply this number times whatever it is. And it told us down here toppings was x. So it means we have to do 2 times x, which means 2 is my m. And we know he has to pay $8 already. So that's your b. So you can use any representation it gives you to write your equation. So I'm just going to plug that in. Y equals 2x plus 8 is our equation. All right, so now using that same problem, we're going to answer some questions. So what is the initial value or cost of the pizza with 0 toppings? So you can look back at your graph, your table, or just the word problem. And the initial cost is $8. Regardless of how many toppings he gets, he has to pay that $8. So B, where do you see the initial value in each representation? So in the graph, it is the y-intercept, or where it crosses the y-axis. In a table, it's where x equals 0. And then if you just look in the equation, it's where b equals whatever. So in this in this case, b equaled 8. All right, C, what is the rate of change for the situation? Remember, rate of change is just the slope. So I'm going to write that right here, our slope, because you can use any representation to find it. But remember, in our graph, you just do rise over run. In the table, you do your change in y over your change in x. Sorry. And then in the equation, it's just where your m equals whatever. And in this case, our m equaled 2. And look, on D, it asks, where do you see the rate of change in the equation? We already said it is our m, and in this case, m equaled 2. All right, so now it is time for your knowledge check. You must get an 80% on the questions in order to move on. If you do not, please go and do the win time and make sure you put these notes in your journal. Good luck.